Hello student, today we are going to study demodulation of FM waves. Demodulation of FM waves. Now what is demodulation? It is the just opposite process of modulation. Here I have explained it with a very simple block diagram. The concept is explained. The input to the FM demodulator is frequency modulated signal. Modulated signal which is transmitted and broadcasted and received at the receiver set. Okay. So at the receiver set, the first section is the modulator circuit, and this modulator circuit receives frequency modulated signal in the case of FM demodulation. And the output of this FM demodulator is message signal. Message signal means audio signal or video signal which has to be actually broadcasted or transmitted. That should be received at the ending point, at the receiving point. So via demodulator circuit, that original message signal can be reconstructed. Okay. Now, what is the difference between AM detection and FM detection? Actually, AM detection is basically a rectification, while FM demodulation is basically a frequency to amplitude conversion. Okay. Frequency to amplitude conversion. What FM demodulator performs? It receives the varying frequency in the modulated wave, and that variation of frequency is converted into the amplitude variation in the message signal. That is the output of demodulator. The output of demodulator is message signal which has amplitude variations according to the variations of frequency in the frequency modulated signal which is input to the FM demodulator. Now it is expected to convert the frequency variation in FM wave at its input into amplitude variation, just now I have told, at its output to recover the original modulating signal. Now what are the requirements? What are the requirements of FM demodulator? The very first is the demodulator must convert frequency variations into amplitude variations. Okay, that's why it may be said as frequency to amplitude converter. Now the second is this conversion, frequency variation conversion to amplitude 1. Frequency variation has to be converted into amplitude variation. This conversion must be linear and efficient. It means that for modulated signal where the frequencies are greater, so at the output the amplitude should be greater. Okay. Now third point is the demodulator circuit should be insensitive to amplitude changes. The demodulator circuit should be insensitive to amplitude changes. As we know that modulated signal when performed as frequency modulation, then the amplitude is constant in overall the signal of modulated signal. But during transmission or via traveling via channels and during reception, there may be various reasons to cause variations in amplitude. So at the demodulator circuit, it should be insensitive to the amplitude changes, and only the output should be the replica of frequency change. Okay. And last, it should not be too critical in its adjustment and operation. FM demodulator should have easy adjustment and simple operation also. Now what is the classification of FM Demodulator. There are direct type and indirect type. Direct type frequency discriminator and zero crossing detector. Frequency discriminator and zero crossing detector are the direct type, and indirect type means phase locked loop. When we say direct type, means we are doing the conversion in single step, one step. But when we say indirect type, means 2-3 steps are involved. Among these three, we will watch only these two, zero crossing detector and phase locked loop, which are mostly used. Now, what is zero crossing demodulator? It is also known as zero crossing detector. A simple effective FM demodulator is one which takes a time average of zero crossings of the FM signal. Now here we can see that this is the frequency modulated signal, where here frequency is lesser and here the frequency is greater. So what we need, that in the demodulator we should generate at zero crossing point, we should generate some pulses. See, you can watch here, when it is crossing from negative side to positive side, means zero crossing point, there is a generation of pulse, and all pulses are of equal width. Pulse width is same, but the pulses are generated at only the zero crossing point. This point, then this point, only the zero crossing point when the wave is crossing the axis line. Each pulse in the pulse train is of fixed width and is located at the zero crossing of the FM signal. And this is the pulse repetition rate modulated signal. This is pulse repetition rate modulated signal. If the pulse train is passed through a low pass filter, if this pulse train is passed through a low pass filter, the filter will perform an averaging operation. Mind it, the filter will perform an averaging operation, and due to this, the rate of change of the average value is related to the message frequency, and the magnitude of the change of the depth of modulation at the generator. Again I am repeating, this rate of change of average value is related to the message frequency, and the magnitude of the change to the depth of modulation at the generator. We will watch it in depth. Okay, let us move. Now see here, I have shown it with a bigger diagram. This is a bigger diagram. Here the first one is of the modulated signal that we are receiving at the input of the zero detector circuit. This is a received signal, which is the modulated signal. Now here you can see that here frequency is low, here frequency is greater because the waves are thicker here. They are nearer to each other, the cycles are nearer to each other, and here they are widened. It means that the frequency is lower. So you can watch at a glance that here the frequency is greater, here the frequency is lower, and the frequency is of varying nature. Now, due to channel nonlinearity or due to any other reason, the modulated signal, which was actually at the generation of modulator, which was of fixed amplitude, here we are watching that some variation in the peak values. Okay, whatever be the reason for these variations, now what we have to do, we have to pass this signal with a limiter circuit. Limiter circuit. So what that limiter will do, the limiter will pass the signal with constant amplitude. Now here you can watch that here this is the limited and filtered signal SFT, means this signal when it is passed through a limiter circuit, limiter is an electronic circuit which limits the amplitude, means it fixes the peak values. Okay, so the positive peak and negative peak are now fixed of a constant amount, and the variations now we are not able to watch. Limiter only control the peak amplitude. It is not changing the frequency. Frequency is as it is, as it in received as ST. Okay. Now after this, an electronic circuit which is known as zero crossing detector is put, and the input to the zero crossing detector is this limiter output signal. And here what you can watch, that for every zero crossing, whether the wave is crossing from positive to negative or negative to positive, for every zero crossing you are getting a pulse or you are getting a spike. Okay, here you can watch, for crossing negative to positive values there is a generation of positive spikes, and for crossing positive to negative values of modulated signal there is a generation of negative spikes. So both positive and negative spikes we are getting at the output of zero crossing detector whenever the modulated signal is crossing the zero value or axis line. It is producing, zero crossing detector is producing spikes. Now if these spikes or the output of zero crossing detector is passed through full wave rectifier, as we know that full wave rectifier provides unidirectional signal. So here the both directional signal, positive spikes and negative spikes, are converted into unidirectional. So this is the rectifier output. Now we are easily able to watch that all these spikes are the replica of the frequency of the received signal at the demodulator. Where the frequency is greater, here we are watching that the spikes are nearer to each other, means the frequency of the spikes are also greater. Okay. Now what is the next step? The next step for the zero crossing detector demodulation is that this is the complete digital signal. At the zero crossing point we are receiving 1. So this is a series of 0 and 1. This is the complete digital signal. Using this digital signal, what we can do, wherever we are getting the 1, we can generate pulse of equal widths. So here we are watching that there are equal widths pulses available at each spike point. Okay. Now if these pulse generator output, which are having many pulses of equal width, are passed through the low pass filter, which is having a threshold value. So like this, here you can watch that where the frequency is greater, if the frequency is increasing, then the amplitude is increasing, and if the frequency is decreasing, then the amplitude is decreasing. And this low pass filter output is actually the message signal which we are getting. Okay, so here I tried to explain the complete concept by using the waveform. Now we watch the circuit also. Let us watch the circuit also. This is the circuit. This is the circuit. Okay. Here this is the limiter. The FM signal is received by limiter. The limiter output is received by zero crossing detector, which is providing bidirectional spikes, and the full wave rectifier converts the bidirectional spikes into unidirectional, and the output of this full wave rectifier will be the complete digital signal having 0 and 1s, and the pulse generator will receive those digital signals, and according to each high signal, it will generate pulse of equal width which will pass through